Hello, everyone. Thank you for joining my Takeaway Thursday today. We will be talking about WSL. So, what exactly is WSL? Well, it stands for Windows Subsystem for Linux, and it was designed by Microsoft, obviously the people who created Windows, and Canonical, the people who created the Linux distribution Ubuntu. Now, WSL acts as a kernel compatibility layer for Windows. So basically what it does is it allows you to develop in a semi-Linux environment and convert any of the calls towards a Linux kernel into calls that a Windows kernel can understand. So it's effectively adding a Linux toolbox to Windows. What I mean by this is it adds a lot of the tools like grep, sudo, apt install, all of the things that you might be used to in a more Linux environment. But now you might be wondering, why would you want to use this over just booting up a VM in something like VirtualBox? Well, the answer is, apart from the comfort of using WSL, is its small resource footprint. The lightweight utility VM that WSL works in it uses very few resources and it's quite fast with the newer versions. Now, in the newest version, WSL2, which came out not that long ago, probably close to a year ago, uh, you might wonder if you should be using it over the previous version, because both are valid, they just have different uses. And there are cases where you'd still want to use WSL1, but I think for the majority of people, version 2 is just going to be superior. So why is that? Well, the first one's architecture is completely different. It uses a translation layer between your Linux environment and your Windows kernel. All Linux system calls would first go through this translation layer, get converted to Windows system calls, and then Windows system calls come out. So that is kind of an issue because not all Linux system calls can be directly converted to a Windows system call. Whereas the second version's architecture, which guess I can quickly show you, is completely different. You will have your Windows user who interacts directly with a Linux user mode inside this lightweight utility VM. And that user mode makes calls directly to a Linux kernel. And that means that you're getting basically native performance with native system calls. And as you can see, you can still make your Windows calls to the kernel and directly to a Linux kernel. And then hypervisor is the platform that will be managing your multiple utility VMs because WSL can actually use multiple distros at the same time. So now another reason is because the first version relied heavily on the WSL team to update anything that happened with the kernel, since it had to manually translate all system calls. So a nice thing about the second version is that it's fully serviced by Windows updates. This means that whenever your Windows 10 has a new update, you just let it update and it will update your WSL to the latest version. And another big thing is the file I/O. The first one was a great attempt, and it's definitely not bad, but it just doesn't have that feel of working in a native environment. So the second version really updated that, and now it has insanely fast I/O in comparison for some operations. A file I/O operation such as git clone is anywhere from 2 to 3 times faster, whereas something like unarchiving a tarball can be up to 20 times faster in WSL2. So now, what exactly do you need to use WSL? Well, you need to have a 64-bit version of Windows 10, a relatively new build, and you need to actually enable WSL in your Windows. Luckily, this doesn't require you to download anything extra because it's actually pre-built and it's an optional feature. My preferred way to enable it is a single line in PowerShell, but there are a couple of ways you can do it, including using Windows GUI. The last thing, obviously, you'll need is a Linux distro. And you can have multiple distros, as I've previously mentioned, and they can be downloaded directly from the Microsoft Store. I personally use the Ubuntu 20.04 LTS version, but yeah, you can use anything. So now just a little quote from me, because as you will find out, I'm quite an avid fan of using VS Code. So anything worth developing is worth developing in VS Code. And now we get into how does it simplify Windows development? Well, for starters, WSL is actually a Windows binary. That means that it's an executable and executables can have operations piped into them. And I'm actually going to show a quick demonstration a little bit later that will show you just how useful this can be. And the second reason is obviously the amazing editor known as VS Code. It integrates seamlessly with WSL thanks to an extension it has that I believe is called WSL Remote Development. And basically the way that works is it allows you to run a headless VS Code server in the Linux distribution of your choice while running the VS Code client in your Windows environment. Now, I don't like talking that much, so I'm going to show you a little demonstration. So now let's just hope that everything goes well. So I'm quickly going to show you, this is, by the way, PowerShell, and maybe let me just make this a bit bigger in case you can't see. So I'm just going to show you a very standard PowerShell command. So simple output, hello from Windows, and then hello from Linux. So when I enter this, it's just going to do what you'd expect. It's just going to output that string over 2 lines because of the new line character. So pretty boring, just working with PowerShell. Now I'm going to pipe this command into a Linux distro using WSL. Like I mentioned, it's a Windows executable, so I can actually just call it directly. Normally, you would actually have to call it by doing it like this, but I have some paths set up so I don't have to type that. Now I'm going to use WSL. I'm going to choose a specific distribution. I have one called Kali Linux, and I'm going to use a tool from Linux called grep, and for the string Linux. So now when I enter this command, you'll see that it's going to only output the line that contains the string Linux. So there I've just used a single command and I've worked across 2 different operating systems. Now that in itself is already pretty cool, but it can go a step further. WSL allows you to use multiple distros at the same time. So now I'm going to pipe it into a second distro I've got running, and I'm going to use Calce. There we go. Now I've just done a single operation in a single line across 3 different operating systems. So that's already a pretty good show of why Linux is useful, but it's quite an arbitrary example. So let me see if I can show you a different one, which I should probably now, by typing in just WSL, I'm actually going to go into that Linux distro. So now I'm currently in my Ubuntu because it is my default version. And I'm quickly going to just start my Apache server. Okay, cool, it worked first try. Normally I have to use sudo to force it. Okay, so then let me quickly get my IP address. So now I'm back in my Windows browser. I'm just quickly going to slap that IP address. And there we go. This is a page that's being served directly from my Ubuntu distro. So now I'm going to show you why the VS Code extension can be very handy. So code is a terminal command to open up VS Code in a specific terminal or on a specific file. And I'm just quickly going to do it for var www.html, which is the directory that Apache serves files from. Now it's going to run the VS Code backend headlessly in my Linux distro. And as you can see, it's opened up the client in my Windows. So now I'm just going to quickly change something on my Ubuntu. Save that, and I'm able to save this in that directory because I own the directory, in case someone was wondering why I could just edit that. And refresh, and there we go. Now I was able to do some pretty quick changes, serving a file from Apache, and yeah, I think that's a pretty good show of why web development is also a lot easier if you use WSL with Windows, because Apache is pretty nice as a server. Then since I am the only person talking, I guess I can also show you how I personally would use VS Code. So what I just showed you was how to run WSL backend headless in Linux and then front end in Windows. I personally actually prefer to just run VS Code in Windows and then just use WSL as my shell. So as you can see right now, this is just running directly in my Windows environment. And all I do is I open up WSL in my terminal. So here I've just got a main CPP with a make file, and now I don't know if you're very comfortable with Windows or C++, but if you were to just try and run the make command to compile this C++ file, obviously it's not going to know what you're talking about. Whereas since I'm now running this directly in Linux, I can just go make. It's going to call the make command. I can do make run. And again, I should probably check to see if you can actually see that. Can I zoom this in? Okay, well, I don't know how to zoom it in right now. But yeah, oh, there we go. So there we can see that it was able to run the program natively writing C++ in VS Code on Windows. Pretty handy.